Good afternoon, and once again, welcome to my YouTube channel. We are discussing Excel International GCSE 9 to 1. This is book 2 of mathematics, and we are still explaining topic number 1, number 6. And this time round, we are on page 8, whereby we will discuss about inverse proportion. And before I say anything, I want us to look at the table under activity 1, which is on page 8. And we are told that Ethan and Mia are planning a journey of 120 kilometers. And they first work out the time it will take them traveling at various speeds. Of course, the secret behind inverse proportionality is that when one quantity increases, the other quantity decreases at the same rate. When we drive at a very high speed, and all of us will bear me witness that to travel from Nairobi to Mombasa, it will take you a very short time. But when you drive at a very low speed, then you will take a lot of time to drive from Nairobi to Mombasa. That is rather natural. But I want us to look at activity 1, or the key points under there. We need to understand that when two quantities are inverse proportion, I'm here, I'm just here. When two quantities are in inverse proportion, the graph of the relationship is a reciprocal graph, a graph that is shown here, this graph that is shown here. When one quantity is very high up there, then the other quantity, call it x, is very low. But when x increases, y continues to decrease at the same rate. So this is what we now call a reciprocal graph. Now, point number 2, one quantity increases at the same rate as the other quantity decreases. For example, as one doubles or multiplies by 2, the other one is supposed to be divided by 2. Their product is constant, and this is key. This is quite important. I want us to underline this point because their product at any given time is simply constant. This is what we mean. When we are talking about inverse proportionality, we have a graph that looks like this. We have inverse proportionality. When we have one product that is very high, the other product is quite reduced. When this one reduces, the other one increases, assuming this is y and this is x. When one now reduces completely, the other one keeps increasing. But of most importance, the product is that the product is constant. The product is constant. We will get to understand this once we now start answering example number 2. And I want us to go straight to example number 2. And we are talking about the emergency service are planning to pump out a flooded area. The number of pumps needed, N, is in inverse proportion to the time taken in days, T. It will take 6 days using 2 pumps. Now, we will talk about the number of pumps. Let's just talk about the number of days. And remember, they are inversely proportional. We need how many pumps? We need 2 pumps rather, to take 6 days. So part A of the question is asking us, how long will it take using 4 pumps? How long will it take using 4 pumps? The question is there. And before we go far, the reason why I told you to underline this statement is because it's going to come in handy to assist us solve this question. If you are careful, you are keen, you realize that 2 times 6, the product is 12. Now, we need to maintain the product. So 4 times the number of days should give us 12. So what is the number of days? Of course, 12 divided by 4 is 3. So we need 3 days we will spend 3 days when we are using 4 pumps. Of course, I will give you the other approach here. The question is on days, so we have 6, approach number 2, and then we come and ask ourselves a question. It took us 6 days with 2 pumps. Now that we are using 4 pumps, will it take us longer or a shorter time? Of course, when the number of pumps increases, the number of days will come down, and therefore we check in the smaller fraction between 2 and 4, which is 2/4. And of course, we are going to understand a lot of things. What gives us this one is by 2, 2, by 2, 3, and then by 2, 1, by 2, 1. Eventually, we're going to have 3 times 1, which is 3, which is also reflected in the first approach. That is as far as part A is concerned. Let's look at part B of the same question. How many pumps are needed to do the job in 2 days? The question is under pump, and the days 2 days. Do you know something? The product is a constant. So it should give us 12 because the product is always 12. So as far as I'm concerned, we are going to have x times 2 should give us 12. And of course, if we say the number of pumps to be P, if we make the number of pumps to be P, so 2 times P, meaning 2P, is going to give us 12. So to make P the subject of the formula, we divide both sides by 2, both sides by 2. So basically, we need 2 pumps. We need 2 pumps. 6 pumps rather, not 2, but 6. 12 divided by 2 is 6 to clear the water in 2 days. And that is it. The second approach, the question is on pumps. Pumps, and therefore, we had 2 pumps. We have 2 according to the information that was given to us initially. The question is on pumps. So 2 times what? If we are going to take, if with 2 pumps we took 6 days. Now we are going to take 2 days. What do you think has happened? Do you think the number of pumps have increased or they have been reduced? We took 6 days. Now we are going to take 2 days. Obviously, the number of pumps have been increased, and then we take the bigger fraction between the two, which is 6/2, of course, by 2, 1, by 2, 1, and the answer is easily 6. Again, the same answer we got in the first approach is the same answer we are getting in the second approach. So please note there are 2 approaches here. The product is always a constant. So long as we are talking about inverse proportion, the product will remain constant. Of course, you can go the way of asking yourself those very simple questions, and the answers will always be the same. So again, visit my YouTube channel, Pearson and Excel International Maths, and subscribe and share widely, and let us work together. All right. Next, we'll be discussing about fractional indices, but that will be explained in a different video. Thank you so much.